Here we go again. Today is Friday, and I'm wearing a hoodie again. It's my dirty hoodie. It has some paint on it. Anyways, we're back to talking about some chemistry. We're going to talk about elements and how they bond together to form molecules. But first, there's a difference between molecules and compounds. Some people think there isn't, but there is. For example, H2O. Water. It's made of two or more elements, right? H2O, two hydrogens and one oxygen. And then you got hydrogen gas. It is just hydrogens connected together, if you look at that. Hydrogen always travels in twos. Now it only has two elements of hydrogen, atoms, elements of the same kind, therefore it's a molecule. H2O, on the other hand, doesn't, because it has two hydrogens and one oxygen, so it's made of more than one type of element, and therefore it's a compound and a molecule at the same time. All compounds are molecules, but not all molecules are compounds. Make sense? I think so. Remember, just think about water and hydrogen gas. Water is a compound because it has two different types of elements, and hydrogen gas is not a compound because it's just made of one element, so therefore it's only a molecule. We need to figure out how these molecules bond, and we got to go back to the periodic table again. In my last video, I talked about how each row has a different number of energy levels that those elements have. For example, row 1 has 1 energy level, row 2 has 2 energy levels, 3 energy levels, and row 4 energy level has 4 energy levels, row 5 has 5 energy levels, and so on. Each one of those energy levels or electron shells can hold a certain number of electrons. And I have a little chart here. This chart shows how many electrons each one of those shells can hold. For example, first row with 1 energy level or electron shell has 2 electrons. The second row, 2 energy levels or 2 electron shells, and that outer shell can hold 8 electrons. And in the third row, they have 3 energy levels or electron shells that can hold 18 electrons. And I'm not going to keep on listing them off, but I'm going to zoom this in for you so you can read them. That corresponds to the number of shells and the number of electrons that can be held in the outer shell of that element. You guessed it, we actually have to talk about the columns too. Each one of those columns tells us how many electrons are in the outer electron shell of each atom. Remember how in the rows told us how many electron shells are in each atom? Each of the columns tells us how many valence electrons, which are the electrons in the outer shell that help bond with other elements or create a chemical reaction. It really depends on those electrons. So we gotta go back to the periodic table. We actually will ignore these elements in the middle. They're called transition metals. They don't bond well with the other and they don't react well. Since their outer shells are full, they don't really bond well with other elements. But on the other columns, they don't have full outer shells that are full of electrons. Therefore, they can bond with other elements. All the elements in the first column only have 1 electron in its outer shell, no matter how many shells that there are. The first row, there's 1 shell, but hydrogen only has 1 electron, so it's in the outer shell. On column 2, guess what? An outer shell only contains 2 electrons, no matter how many shells that you have. And then if you jump all the way over here, we're skipping the transition metals because they don't bond well with others. They don't play well with others.
I don't play well with others.
We go all the way to 13. So we go 1, 2, 3. 3 means there's 3 electrons in all those elements in that column. Same way, and this is going to be 3, 4 electrons in the outer shell, 5 electrons in the outer shell of all these elements, and so on, all the way until you get to 8 electrons on the right column. But remember, this is just the amount of electrons in the outer shell. And this is going to actually help us create a Bohr model, which is what I'm going to talk about next. And you're going to have to do that for homework for the next 2 days. Sorry guys, I know how you love homework. Actually, it's not really homework because you're at home all the time now, so I guess it's remote learning work? I don't know. I guess that's what we're going to call it now, remote learning work. Now that we know how many electrons are in each shell of each atom, by using the top 7 rows, we need to use that information to create a Bohr model, which I'm going to have you guys. To create a Bohr model, you need to have something like this. This actually shows a couple different atoms. This is what I actually give you to do for work. You can either print it out, or I can show you how to put electrons on this document without having to print it out. I'm going to show you how to do that too. But you also have to have your periodic table that shows all of the atoms. First, we got to remember the number of protons is the atomic number, and the number of protons in each atom is equal to the electrons. So we know that. So we know how many electrons are in each atom. It's easy. And the number of protons is equal to the number of electrons in the atom. So for example, we're going to do a quick one first. If you go to the hydrogen, it's number 1. We know it has at least one proton and an electron. So we go here, and we're going to create a little circle, and that's going to be our electron, and we're going to make it red. Make it red by putting it the fill color as red. And we're going to make a small little dot, and we can copy and paste these things all over the place, and they're going to be our electrons. But we know hydrogen has 1 electron, so we're going to click on here and write 1 electron, because you got to figure out how many electrons each one of these atoms has. I'm going to do the first 3 with you, and then you can do the rest on your own. And then we're going to drag the electron into that first energy level, because hydrogen, being in the first row, has only 1 electron in its first energy shell, because it only has 1 energy shell because it's in the first row. And then we got to look at potassium. Potassium is awesome. It explodes, which is great. So does sodium. That's why I'm going to show you these, because they're just exciting. Because when you throw them in water, they explode. Fun atom. But I can't actually do that right now because it's dangerous, and I wouldn't do it in the classroom either. Maybe we could do it outside, but I don't know. I don't trust these things. Middle school science teacher. I'm going to lose my job or something. Anyway, we got to look at potassium. Potassium is the letter K on the periodic table. That's its element symbol. It is located, let me see here. K is number 19. And since it's in the 4th row, we know has 4 electron shells. In each one of those shells, remember, we have that little chart that I'm going to give you also. The first level, there is a command kit. And I'm going to click one over here. We know that there's, whoa, I'm going to drag it. And we can put 2 electrons on the inner shell, because I know at least the first shell has 2. And then copy another one over here, paste another one, drag it over there. So we got our first shell filled up, because remember, our first shell can only have 2 electrons. And then we go to the 3rd shell, and then we bring out that handy dandy chart. The 2nd level has 8 electrons, so we're going to make 8 electrons and put 8 electrons in that other shell. So and that 3rd energy level of potassium has 8 also. Copy a few more. We're going to make 8 around that 3rd level. And on this 4th energy, it has 1 electron. And that is the Bohr model of potassium. And it has 19 electrons because we know that because of its atomic mass number. And sodium. So let's go back to the periodic table. Sodium is Na. It is third row, so it has 3 electron shells. So, and it has 11 electrons. So it has 11 electrons. Oh yeah, sodium is also an explode, which is pretty awesome.
That's fire, and then it explodes.
We keep making copies of these guys. I don't know why it keeps on ending up being down there. And then it has 1 more electron on its 3rd energy level. That's how you make the Bohr model for sodium. Now, you have a few more to do. I'm going to let you do these on your own. You can do it this way, or you can print it out and take a picture of it and pass it in. I find it's easier if you print it out and just draw the circles on it, because doing this way is a little tedious, and that's how you create the Bohr model. I'm hungry.